today we're going to look at log laws. Now there's a few of them. They're just like index laws, except they're log laws, and they have similarities because they're the reciprocal of one another. Indices and logs are the reciprocal of one another. So that's the title, learning goal, and let's move on. Okay. So the first one, just like anything to the power of 0 equals 1 in indices, okay, so x to the power of 0 equals 1, any log that is 1 equals 0. So if you want to try with me, you've got two buttons of logs, so put the log button, which is log to the base 10, and put 1, alright, so put 1 in. You should get 0, and then the second button, which is the one that I want you to be using more often, which is ln, which is log to the base e, put 1, and you'll get 0. And that's because of the similarities between both the logs and exponentials. And if I can do just a quick line there, so that's an exponential and it crosses at 1. Well, log is that, and that number is actually 1, so it's actually 0 at that point. So log, it doesn't matter what base of 1 is 0, so it's really, really important that you know that one. Okay, the second one that we want to look at is probably the one that gets used the most. If you've got log to any base, and then you've got the number, and then you've got an indice, you can just bring that indice to the front. So for example, if I go log to base 10 of x to the 3, I can write that as 3 log 10x. Alright, so it's really, really important. Now with that one, we can actually do a lot of things. So for example, bringing our index laws, so we go log to the base 10, let's go square root of x, alright? Or I can change the square root of x to something else. I can go log e to the x to the power of a half. That means using this definition here is that I can just make that, I'll put it to the e, didn't I? So e is the way, it should be your favourite. I'll do the next one, we'll do it as e. So 10, I'm going to go as half log 10 to the x. Alright, so I'm bringing that back to the front. Okay, and let's do the last one. I'm going to do log to the base e, log base e, and then I'm going to go 1 over x. Alright, now I can change that to an indice. So I'm going to go log to the base e, x to the negative of 1. So that means that using this law, I can go negative log e to the x, all right? So there's a lot of manipulation that we can do, all right? All right, the next one's really, really important. It will help us solve a lot of things. Essentially, it's just if you've got the same base and number within the log, it equals 1. So let's do a couple of examples. Log to the base 2 equals 1. Log to the base e, and if the number is e, it equals 1. And I want you to try this in your calculator as well. So use those buttons that I talked about it. So this one, the first one's to the base 10. So this one will be, I'll put it down. This one you can try by the LN button, all right, so this is the LN button, this one, all right, so put LN and then put E, and then it should equal 1, and then this one is log to the base 10 button, so try log 10 of 10, and it should give you 1. We've tried that previously in classes, so it should be okay. So there's some really important log laws there. Let's look at some more. Okay. So here, because of the reasons that we just discussed, see if you've got the same base and the same number, let's work it out. So this one, see I can move the x to the front, so it's going to be x to the log a to the a, and that's just x times 1 because of the previous law right here, this one. Okay, and so we get x. Now, inversely, this is true too. Well, try this one. So, I don't know. Try this one in your calculator. Press ln, so I'm going to go log to the base e, and then put e to the power of 17, and see if you get the answer is 17. All right. Now, this one's true too, okay? So if I go 10, and I'm going to put it to the power of, I log with a base 10, see how a and a are the same, 10 and 10 are the same. And let's put 16 in this case. You should get the value of 16. So that's really, really important that we understand that. And if you want to try another one, go e to the power of log base e, and let's try 31, and you should get 31. So that's what this log law is saying. So this button for that one is log, this one is ln. Okay. Now, this is where it starts looking like index laws next to it. If you've got something times something else, remember that what's in between the x and the y is the times, you can split it up into two different logs, and I've actually done this incorrect. That should be plus there. So when we times, we can split it up into two different logs that we can time it. So, for example, if I go log, and I'm going to use base e to the, and then I'm going to put in brackets 3x, all right, I can split that up to log to the base e of 3 plus log to the base e of x. Okay, so I can easily do that. Now, divide is true. Divide is the same, it's just the opposite. Okay, so let's use the same example. So I'm going to go log to the base e, and then let's go 3 over x. So I can change that to log to the base e of 3 minus log to the base e of x. Okay, so, and this is where it starts, yeah, it's looking a lot like normal index laws. All right, that's the end of the lesson. Peace out.